The way AI is evolving, it feels like warp speed sometimes.
It really does.
We're definitely seeing this big shift, right? Moving beyond just single AI models towards these more collaborative multi-agent systems.
Yeah, definitely. Teams of agents.
And speaking of big shifts, Google just dropped something pretty significant at Google Cloud NXT 2025. The Agent Development Kit, ADK. It's got a lot of AI engineers talking.
Oh, absolutely. It feels like a proper step forward for actually building production-ready AI.
Yeah, it does. And what's interesting is that this isn't just theoretical, is it?
Not at all. That's the compelling part. They're using the same framework, ADK, inside Google already.
Oh, really? Where?
Things like Agent Space, their customer engagement suite. So, it's been tested in the real world basically from day one.
Okay, so it's battle tested. That definitely adds weight. So for this deep dive, what's our mission?
Well, I think we really need to unpack ADK, dig into the core pieces, the ADK toolkit itself, the agent engine for running things, the agent garden samples, and that A2A protocol.
Agent 2 agent, right?
Exactly. And crucially, explain why things like the built-in support for MCP, LangGraph, maybe PydanticAI, why that stuff makes ADK such a potential game changer, especially for building serious scalable multi-agent applications.
Right. So breaking down the what and the why it matters for AI engineers looking to build complex stuff. Okay, let's start right at the top then. What exactly is the Agent Development Kit? What are we looking at under the hood?
Okay, yeah. So fundamentally, ADK is an open source framework. It's specifically built for creating AI agents.
Open source, okay.
And it's tightly integrated with Google's Gemini models, obviously, but also the whole Google Cloud platform. What stands out is the flexibility. It's very modular, meaning you can use it for relatively simple single agents, or you can architect these really complex hierarchical systems with lots of agents working together. It's designed as a code-first Python toolkit.
Ah, code first. So aimed at developers who want control.
Precisely. It gives you that fine-grained control, the ability to really express your agent logic using Python code.
Okay. And you mentioned multi-agent systems. That seems to be a core theme. How does ADK actually help you build and, I guess, manage these teams of AIs?
Yeah, that's really central to its design philosophy. They call it multi-agent by design. It's not just an add-on, it's baked in.
Baked in how?
It lets you structure agents in hierarchies. Think of it like an org chart for your AI workforce. You have specialized agents reporting up, potentially coordinating complex tasks.
A hierarchy.
Yes.
That makes sense conceptually. Can you give us a more concrete example? How would that work in ADK code or structure?
Sure. The docs have a simple example, a weather agent and a greeting agent. You can set up the greeting agent as a sort of sub-agent under the main weather agent.
Okay.
Now, here's the clever bit. You give each agent a description, you write what it does, handles simple greetings or provides weather forecasts.
Right.
Then, when a user interacts, say they type hello, the underlying language model looks at those descriptions, it figures out, hello matches the greeting agent's description, and it routes the request there automatically.
Oh, interesting. So it's not rigid if then routing. The LLM itself is making the decision based on the descriptions.
Exactly. Description-driven delegation, it's much more dynamic. You can build these layers of specialists all managed under a root agent and let the LLM handle the intelligent routing based on capability.
That sounds incredibly efficient, actually, letting the AI manage the AI workflow based on their job descriptions.
Okay, so you've designed your hierarchy, you've written the code. How do you get these agents running in the real world reliably?
Right, that's the next crucial piece. The agent engine. Think of it as a dedicated, fully managed runtime environment sitting within Vertex AI.
Okay, Vertex AI, so Google Cloud native.
Yep. It's specifically built for deploying these custom agents to production. And the key is it handles a lot of the operational heavy lifting.
Like what?
Things like built-in testing frameworks, version control for your agents, release management, high reliability, running securely on Google's global infrastructure. It just smooths out that path from development to production quite a bit. So it's the managed infrastructure layer that lets these agents actually operate at scale and reliably.
Precisely. It takes away a lot of the DevOps pain you might otherwise face deploying complex AI systems.
And does it only work with agents built using ADK? Or is it more flexible?
It's designed to be flexible. While it's obviously a perfect fit for ADK agents, the agent engine also supports agents built with other popular frameworks like LangGraph or CrewAI.
Oh, that's a big plus. So you're not locked into only ADK for deployment if you use agent engine.
Correct. It aims to be a more unified deployment platform. And it handles memory, too, both short-term for conversations and long-term persistence. Plus, it ties directly into Vertex AI's evaluation tools.
For monitoring performance.
Exactly. And into Google Agent Space for overall management and discovery. So it's quite integrated.
Okay, that unified deployment aspect across frameworks sounds like a really smart move, simplifying the architecture. Now, for someone just starting out with ADK, is there anything to help them, get going quickly, avoid the blank page syndrome?
Definitely. They have something called the Agent Garden.
Agent Garden.
Sounds nice. It is. It's basically a curated collection of ready-to-use sample agents and various tools, all accessible right within ADK.
So like starter kits.
Yeah, pretty much. The idea is to jumpstart development. You can grab an example, see how it's built, see how it uses tools, and then modify it for your own needs. It's learning by example, which is often the best way.
Absolutely. See working code, adapt working code, much faster. Now, something else that caught my eye was this agent-to-agent protocol, A2A. What's the story there? Sounds ambitious.
It is ambitious, and I think quite forward-thinking. A2A is envisioned as an open standard.
Open standard for what?
For agents built on different platforms by different companies to actually talk to each other and collaborate securely.
Wow. Okay, so true interoperability.
That's the goal. Imagine your customer service agent, maybe built with ADK, needing to escalate a really technical problem. It could securely discover and hand off that task to a specialized third-party troubleshooting agent, even if that agent uses totally different tech.
Okay, that would be powerful. Like APIs for agents.
Sort of, yeah. A common language for them to publish what they can do, negotiate tasks, and interact securely. Google's already building a coalition of partners around this.
If they get buy-in, that could really unlock a more connected AI ecosystem, breaking down those silos.
That's the vision, I think.
Okay, so we have the framework, the deployment engine, sample agents, and a protocol for talking to other agents. What about the brains? The actual AI models driving these things, how flexible is ADK there?
Very flexible. So naturally, it has tight native integration with Google's own Gemini models. That's expected.
Sure.
It also connects easily to the whole Vertex AI model garden, which has a huge range of models. But the really interesting part for many devs will be the Light LLM integration.
Light LM, what's that?
Think of Light LM as like a universal translator for LLM APIs. It provides a single interface to connect to models from loads of different providers.
Like who?
Anthropic, Meta, Mistral AI, AI21 Labs, a whole bunch. So through Light LM, ADK lets you plug in models from basically anywhere.
Okay, that's huge. So you're not locked into just Google models. You can pick the best one, maybe based on cost or performance or a specific capability for each part of your agent system.
Exactly. That model flexibility is a massive advantage. You choose the right brain for the right job.
All right, so flexible models. But agents aren't just about models. They need tools to interact with the world, right? What does ADK offer on the tool front?
Yeah, the tool ecosystem is really rich. You get pre-built tools right out of the box for common things, Google search, executing code safely.
Standard stuff, yeah.
But then you can easily define your own custom Python functions as tools. And it integrates smoothly with libraries developers already know and love, like LangChain and Llama Index.
Ah, so you can bring in existing LangChain tools.
Yes, and even use other agent frameworks like Crew AI as tools within an ADK agent. And critically, it has native support for MCP.
MCP, Model Context Protocol.
That's the one. It's a secure standard for connecting agents to data sources and tools, really important for enterprise use cases where you need controlled access.
Security, yeah. Makes sense. What else can it connect to?
A lot. There are over 100 pre-built connectors for Google Cloud Services. You can hook into application integration workflows, directly query data in AlloDB or BigQuery.
Without moving the data.
Right. Plus, it can talk to standard open API endpoints, so you can integrate with your existing APIs, maybe managed via Apigee. And, of course, grounding responses with Google Search or other specialized data providers is built in.
And I saw something about Google Maps.
Yeah, experimental support in the US for now. But imagine agents that can use location data from maps. Opens up lots of possibilities.
Wow, okay. That's a very comprehensive toolkit. It really feels like they want these agents to be able to do things in the digital and potentially physical world.
That's clearly the intent. Give them the senses and the hands they need.
So you have these agents, they have models, they have tools. How do you actually control the flow? Make them work together on a complex task that has multiple steps.
ADK gives you options for orchestration. For predictable workflows, you can use things like sequential agents, step A, then step B, then C.
Simple pipeline.
Exactly. Or parallel agents to do things simultaneously, loop agents for repetition, so you can define structured pipelines.
Okay.
But where it gets more advanced is the LLM-driven dynamic routing, using something called LM agent transfer.
What does that do?
It basically lets the language model itself decide which agent should handle the next step in a process based on the current context of the conversation or task.
Oh, so back to that dynamic routing idea, but for steps within a workflow.
Precisely. It allows for more adaptive, intelligent behavior rather than just rigid, predefined flows. You get both structured control and dynamic adaptability.
That combination sounds powerful. Define the parts, let the AI handle the ambiguous transitions. Okay, switching gears slightly. For the developers actually building this stuff, what's the day-to-day experience like?
Yeah.
The developing, testing, debugging.
They seem to have put real thought into the developer experience. There's tooling for local development, a CLI, a visual web UI.
So you can build and test locally without deploying to the cloud constantly.
Yeah, makes iteration much faster. And the debugging tools look promising. You get deep introspection.
Right.
You can apparently step through an agent's execution, look at the events firing, inspect its internal state turn by turn, trace the whole flow.
Oh, that's essential.
Oh.
Debugging these complex, sometimes non-deterministic systems can be a nightmare without good visibility.
Absolutely. Having that step-by-step inspection capability is huge for understanding why an agent did what it did and for fixing things when they go wrong.
Okay, so the dev loop seems well supported. Now, once you think your agent is working, how do you actually evaluate its performance properly? Measure success.
ADK has built-in evaluation features for that. It's not just about checking the final answer.
No.
No, it encourages evaluating the entire process, the steps the agent took, the reasoning against predefined test cases. Did it get the right answer for the right reasons?
That's a much more robust way to evaluate. Ensures reliability.
Exactly. And you can do this programmatically using an agent evaluator.evaluate function or through the command line and the web UI tools for looking at results.
Okay, so systematic assessment is part of the package. Now, deployment. We talked about the agent engine and Vertex AI. Are there other ways to get these agents running?
Yep. There's flexibility there too. You can containerize your ADK agents using Docker.
Standard containers.
Right. Which means you can basically deploy them anywhere Docker runs. Locally, obviously. On the Vertex AI agent engine for that managed experience. Or on other platforms like Cloud Run, or even your own Kubernetes cluster if you wanted.
So deploy anywhere. Good flexibility.
Definitely gives you control over your deployment strategy.
And how do users actually talk to these agents? I saw something about streaming.
Yeah, this is pretty neat. ADK has built-in support for bidirectional audio and video streaming.
Bidirectional, so two-way voice and video.
Correct. This opens the door for much more natural, human-like conversations. Think beyond text boxes' actual voice interaction, maybe even analyzing video input in real time.
Wow, that could completely change the user experience for things like virtual assistants or customer support bots.
It really could. It makes multimodal interaction a first-class citizen.
Okay, we've covered a lot of the core parts, but you mentioned some specific integrations earlier. LangGraph, LangChain, PydanticAI, MCP. Why are those particularly worth highlighting for engineers?
Right, so the native support for LangGraph is a big deal. LangGraph is really popular for building complex, stateful conversational agents as graphs. ADK embracing it makes it a very powerful combination for dialogue systems.
So if you already like LangGraph, ADK fits right in.
Exactly. Same goes for LangChain's smooth integration with that huge ecosystem of tools and utilities, and the synergy with PydanticAI.
For data validation.
Yeah, PydanticAI is great for ensuring structured data inputs and outputs with LLMs. Combining that with LangGraph's orchestration and ADK's framework gives you a really robust stack for building reliable AI. It just fits together nicely.
It sounds like they're leveraging some of the best-of-breed tools that AI devs are already using.
That seems to be the approach. Don't reinvent everything, integrate the good stuff. And MCP, the Model Context Protocol, we touched on it, but it's critical.
Why again? Remind me.
It provides that secure, standardized way for agents to access data and tools. In any serious enterprise setting, you need that controlled, secure connectivity. MCP provides a standard for it.
Right. Security can't be an afterthought. So speaking of which, what's the story on responsible AI and general security within ADK?
It's clearly a major focus. ADK includes features and promotes patterns for building trustworthy agents, following responsible AI principles, and being part of Vertex AI brings a lot of enterprise security features along for the ride.
Such as?
Things like fine-grained control over agent outputs using Gemini safety features, managed permissions via IAM, network security with VPC service controls, the ability to set up specific guardrails to limit agent behavior, plus automatic monitoring for anomalies.
Okay, so a pretty comprehensive security posture built in.
Yeah.
It really does sound like they've thought about the whole life cycle, from building to deploying responsibly. Now, one last clarification point. Google also has GenKit, right? Another AI framework. How does ADK compare? When would you use which?
That's a good question. The way Google seems to be positioning it is ADK is really optimized for those complex multi-agent systems we've been talking about. It offers higher-level abstractions specifically for that. Plus, the built-in LangLM and Vertex Model Garden support is geared towards that kind of sophisticated agent building.
Okay, ADK complex multi-agent focus. What about GenKit?
GenKit is framed as providing more fundamental building blocks for a maybe broader range of AI experiences, not just agents. It has strong tooling for iterating and debugging across different AI interaction types, and potentially wider model support via its plugin system.
So more general purpose, perhaps.
Kind of. It really boils down to your project goal. If you know you're building a sophisticated system with multiple collaborating agents, needing strong orchestration and diverse model support out of the box, ADK looks like the more direct path. If you're building something else AI-powered or need ultimate flexibility on models via plugins, GenKit might be the better fit.
That makes sense. Choose the tool that's most optimized to the specific job. Okay, let's pull this all together. Why is ADK, this whole package, such a big deal for AI engineers right now? What's the core takeaway?
Well, I think fundamentally it just makes building sophisticated AI, especially multi-agent systems, significantly less complex. That's the main thing.
Simplifying the complex.
Yeah. It gives you a structured way to build these modular, scalable AI teams that can tackle problems too big for one model. The flexibility in choosing models, the rich tool ecosystem, the data connections, those are huge practical advantages.
And the path to production.
That streamlined path via the agent engine is a massive win. Reduces friction, gets things deployed faster and more reliably. And the commitment to open standards like A2A and MCP, that points towards a more interoperable future.
Right. Less lock-in, more collaboration potential.
Exactly. Plus, the built-in evaluation and the strong security features give you the confidence to build and deploy things that are actually trustworthy. So for an AI engineer, ADK really looks like a powerful, integrated toolkit designed to help them build the next wave of more capable collaborative AI systems much more effectively.
Okay, so wrapping up our deep dive on the agent development kit, we've seen it's this potent open source Google framework, really tailored for creating AI agents, especially those complex multi-agent setups. Key parts are ADK itself, the agent engine for deployment, the agent garden for samples, and that forward-looking A2A protocol.
Right.
Plus, the integration with crucial tech like MCP for secure data, LangGraph for orchestration, PydanticAI for reliability. It all adds up.
It really does feel like a cohesive platform.
Yeah, it seems like a very deliberate move to standardize and simplify how we build, deploy, and manage these more intelligent collaborative agents in the real world.
I agree. And maybe that leads to a final thought for the engineers listening.
Go for it.
Think about the really complex workflows in your own field, the ones that currently need lots of human coordination, maybe juggling different tools or data sources.
Okay.
Now imagine designing a team of specialized AI agents using ADK that could automate or significantly streamline that exact process. How could you combine a data analysis agent with a reporting agent, maybe with a customer communication agent? ADK provides that foundation to start building those kinds of sophisticated, automated workflows. The potential is really there now, more accessible than before.
That's a great challenge. Thinking about applying this power to real-world complex problems, a compelling vision. If folks want to get hands-on and learn more, where should they go?
The official Google Cloud documentation for ADK is the best starting point, and the ADK GitHub repository has the code and more examples.
Perfect. We'll make sure to put links to those in the notes for this deep dive.
Yeah.
Thanks for unpacking ADK with us today.
My pleasure. Lots to explore there.
Definitely. And thanks, everyone, for joining us.